Let's solve a couple of equations that are related to quadratics. Starting with this one, x to the fourth is equal to 15x squared plus 16. This is definitely not a quadratic because there's an x to the fourth in it. So I'm not sure how to solve this. Maybe I'll start by subtracting 15x squared and 16 from both sides of my equation. Changing this to x to the fourth minus 15x squared minus 16 is 0. I want to somehow change this equation so it becomes a quadratic because I have a bunch of strategies for solving that thing. So how would I go about doing this? The key observation is to note that x to the fourth is the same thing as x squared squared. So I'm going to replace that. X to the fourth is x squared squared. And here I can even put the other x squared in parentheses too. These two equations are equivalent because I can multiply these two exponents to go back to x to the fourth. It's at this point where I'm like, wait a second. If this was just one variable equal to this one, I actually do have a quadratic. A nice way to write this is to replace x squared with a different variable, which I'll call y. So I'm going to let x squared equal y. If I do that, I've changed my equation. It's now y squared minus 15y minus 16 is 0. I don't really need those parentheses around the y's. That's, again, y squared minus 15y minus 16 is 0. So what we've done is we took this equation, which was not a quadratic, let y equal x squared, and changed it to a quadratic equation. I'm now going to solve this thing using all the strategies that we have, and then hopefully figure out what the values of x are that work in the original equation. So it's like a new problem. I want to solve this thing for y. Now how would I do that? Well, okay, we could try to factor, we could try completing the square, but I'm going to directly go to using the quadratic formula, where a is equal to 1, b is equal to negative 15, and c is equal to negative 16. I'm going to take that information and plug it into the quadratic formula. And note that y is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I'll just point out that I can call this y because it's referring to the variable in the quadratic equation. My goal is now to simplify this whole thing. I can mostly do this in a calculator. We get 15 positive because of the negative and the negative. I'm going to type this thing in my calculator. Negative 15 squared plus, let's see, negative 15 squared minus 4 times 1 times negative 16 is 289. And that's all divided by 2. The square root of 289 is 17. So my two solutions will be 15 plus or minus 17 all over 2. If I break that up into two solutions, that is y is equal to, okay, 15 plus 17 is 32, divided by 2 is 16. If I do 15 minus 17, that's negative 2 divided by 2, which is negative 1. Those are my two solutions, but they're for y. The ultimate goal is, what is x? So I have to go back to this equation here. To solve for x, I'm going to take that equation and put 16 in place of y. So x squared is equal to 16. But I have to do the same thing for negative 1. X squared is equal to negative 1. I have to solve these two equations if I want to figure out x. But the good news is we have a property that will do this for us. I can take the square root of both sides, and I get that x is equal to plus or minus 4. If I do that over here, I get x. The square root of 1 is 1, but if you have a negative under there, I'll just call that I, plus or minus I for imaginary. So this equation technically has 4 solutions: positive 4, negative 4, positive I, and negative I. And those are the solutions to the original equation. But just to recap, we started with something that was not a quadratic. I made an observation that by switching things around a little bit, it became quadratic. I then solved this equation for y, but then at the very end had to go back and figure out what the corresponding x values were. All right, let's solve one more equation that relates to quadratics. Here I have 2x to the, that's supposed to be 6, minus 8x to the 4th. To solve this one, I think I want to remove a greatest common factor from both terms, which I see I can remove a 2 as well as an x to the 4th. If I do that, if I factor out a 2x to the 4th, what is left over is x squared minus 8. And my goal is to figure out, well, where is this thing equal to 0? And as we've seen earlier, you can figure out where each individual factor is equal to 0. So you can break this apart. A product is equal to 0 if the two individual pieces are 0. And let me just correct that this really should be a 4. It's these two separate equations that I need to solve. This one's really simple. I can divide both sides by 2. I get x to the 4th is equal to 0. And can you think of a number that would make this equation true? There's exactly one, and that number is x is equal to 0. Anytime that you have x to a positive integer, the solution has to be 0 and only 0. But that takes us over here to, well, okay, x equals 0, definitely a solution. If you go back to the original equation and put 0 into all the x's, you get 0 is equal to 0. No problems there. But what about this thing? Okay, to solve this thing for x, I'm going to start by adding 8 to both sides. I get x squared is equal to 8. And to get this one, I want to take the square root of both sides, which gives me x is equal to plus or minus the square root of 8. So it looks like there's 3 solutions: 0, positive root 8, and negative root 8. I think one thing to point out is you can simplify the square root of 8 a little bit. If you make a note that 8 has a perfect square in it, it's equal to 4 times 2. The square root of 8 is the same thing as the square root of 4 times the square root of 2. But if you take the square root of 4, you get 2. It leaves you with the square root of 2 under the root symbol. You can actually write this as plus or minus 2 the square root of 2. So if I were to write out the 3 solutions, they are x is equal to 0, x is equal to the positive 2 root 2, and also the negative of 2 root 2. And those are the answers to this equation.